Welcome students, this is video lecture 4 of module 1, that is Introduction to Energy Science. As we all know, energy growth is directly linked to well-being and prosperity across the globe. Meeting the growing demand of energy in a safe and environmentally responsible manner is a key challenge. वैश्विक बाजार की अनिश्चितता के समय में एक बात जो हम जानते हैं कि दुनिया को ऊर्जा की जरूरत है और वो भी इंक्रीजिंग क्वांटिटी में, जो इकोनॉमिक एंड सोशल प्रोग्रेस के लिए सपोर्ट के रूप में बेहतर साबित होती है। लेकिन इस दुनिया भर में ऊर्जा को प्रदान करना हमारी जिम्मेदारी है और कमिटमेंट भी है इकोनॉमिक डेवलपमेंट के लिए। लेकिन हमारे रिसोर्सेज को कंजर्व करना भी तो हमारी ही जिम्मेदारी है। So we are committed to protecting both people and the environment and making positive economic contributions. Reliable energy responsible होती है expands industry के लिए, modern agriculture के लिए, trades and transportation के लिए. So हम कह सकते हैं reliable energy resources are the building blocks that help people escape poverty and create better lives. आज दुनिया की अधिकांश एनर्जी हाइड्रोकार्बन से आती है एंड क्रूड ऑयल मेन ट्रांसपोर्ट फ्यूल है। यहाँ तक कि बेहतर एनर्जी एफिशिएंसी में भी महत्वपूर्ण प्रगति के साथ वर्ल्ड एनर्जी डिमांड 2020 से 2040 तक लगभग 25% इंक्रीज होने की उम्मीद है। डेवलप्ड कंट्रीज एंड डेवलपिंग कंट्रीज इस बढ़ती डिमांड को पूरा करने के लिए सभी ऊर्जा उत्पादनों में वृद्धि करना चाहती हैं एंड रिन्यूएबल एनर्जी रिसोर्सेज अलोन विल नॉट कीप अप विद द डिमांड। ऑल सोर्सेज ऑफ एनर्जी आर नीडेड। इसका मतलब यह है कि तेल और गैस की बढ़ती डिमांड ने हमारे इन एनर्जी रिसोर्सेज को समाप्ति की ओर ला दिया है और हम अनकन्वेंशनल ऑयल रिसोर्सेज का यूज करना होगा, जैसे ऑयल बेयरिंग शेल एंड सैंड। लेट अस डिस्कस अबाउट ऑयल बेयरिंग शेल एंड सैंड। Next topic is oil bearing shell. We will discuss its introduction, extraction, process of fracking, advantages, disadvantages and scenario. Now introduction. Oil bearing shells are underground rock formations that contain trapped petroleum. ऑयल बेयरिंग शेल्स जो है वो अंडरग्राउंड रॉक फॉर्मेशंस होते हैं जिनमें पेट्रोलियम ट्रैप्ड स्टेज में होता है। The petroleum trapped within tight geological formations with low permeability and low porosity is known as tight oil and it is difficult to extract. लो परमिएबिलिटी और लो पोरोसिटी के साथ ऑयल जो है टाइट जियोलॉजिकल फॉर्मेशंस के भीतर ट्रैप्ड होता है, इसलिए हम इसे टाइट ऑयल भी कहते हैं और इसको एक्सट्रैक्ट करना आसान नहीं होता है। परमिएबिलिटी फ्लूइड की फ्लो एबिलिटी होती है और पोरोसिटी उस फ्लूइड को धारण करने की कैपेसिटी होती है। Because of these unique geological conditions, tight oil requires advanced drilling techniques like hydraulic fracturing या fracking. इस वीडियो के थ्रू हम हाइड्रोलिक फ्रैक्चरिंग और फ्रैकिंग प्रोसेस को समझ सकते हैं।
Fracking. Hydraulic fracturing, or as it is commonly called, fracking, is a drilling technique used for accessing natural gas and oil in tight geologic formations. The process involves the horizontal, directional drilling of wells, as well as the use of water, sand, and chemicals at high pressures to fracture rock and release hydrocarbons. The hydraulic fracturing process can be summarized into the following steps. A well is drilled vertically to the desired depth, then turns at an angle and continues horizontally for several thousand feet into the formation containing the trapped natural gas or oil. A mixture of water, sand, and chemicals are pumped into the well at high pressure in order to create fissures in the rock, which increase permeability and allow the hydrocarbons to escape. Natural gas or oil is released through the fissures and is drawn back up the well to the surface. Wastewater, also called flowback water or produced water, returns to the surface after the fracking process is completed. The natural gas or oil is collected from the surface and processed, refined, and shipped to market. Water and sand make up 98% of the fluid used in hydraulic fracturing. In addition, chemical additives are used, but the exact formulation varies depending on the well. Because of the advances in the fracking technology, oil and natural gas that were previously unrecoverable are now accessible. This has led to an increase in supply of both oil and gas in the world market and has meant greater energy independence for those countries, such as the United States, that can now access an abundance of these resources. However, the development of fracking has been controversial due to environmental concerns. The process typically requires 11 million liters of water per well, but can vary greatly depending on the characteristics of the geologic formation. Other environmental concerns include contamination of groundwater, depletion of fresh water, and surface pollution in the drilling process. There are also concerns linking fracking to enhanced seismic activity. That's fracking.
Now, advantages and disadvantages of oil-bearing shell. Now, advantages. It reduces the energy dependency. It can be used instead of coal, which is more contaminant. It balances the oil prices. It breaks the monopoly of oil exporting countries. It has the power of providing employment. It has the power of improve the economic indicators. Now, disadvantages. It is a resource which quickens the global warming and may be one of the reasons of earthquake. Its production is highly costly. It may pollute the water sources. Continuity of uses of fossil fuels. Negative environmental and social reactions. Infringement of habitat. Changes in underground structures. These are the advantages and disadvantages of oil-bearing shell. One more disadvantage is here, disputes between global companies and local residents also. Now the scenario. Technically recoverable proven tight oil or oil-bearing shell reserves worldwide as of 2016 by country in billion barrels of oil. Iran has maximum reserve of oil-bearing shell with 158 billion barrels of oil. So we can see Iran, Russia, United States, China, Argentina, Qatar, Australia, Mexico, Canada, Algeria, Turkey and Poland are the oil-bearing shell providers worldwide. The Government of India has carried out studies through various national and international agencies for the identification of oil-bearing shell resources in the country. And India holds promising reserves like sedimentary basins of Kombe, Gondwana, Krishna Godavari, Kaveri, Indo-Gangetic, Assam and Assam-Arakan basin. Estimated technical recoverable volume of approximately 62 million barrels of oil-bearing shell. Now, oil sand. We will discuss its introduction, processing, advantages, disadvantages, and scenario. Now, the introduction. ऑयल सैंड या तो लूज सैंड होती है या आंशिक रूप से कॉन्सोलिडेटेड बलुआ पत्थर है, जिसमें रेत, मिट्टी और पानी का स्वाभाविक रूप से मिश्रण होता है, जिसमें घने और बेहद चिपचिपे सब्सटेंस के रूप में पेट्रोलियम होता है, जिसे बिटुमिन कहते हैं। बिटुमिन बहुत विस्कस होता है एंड रिकवर किया जाता है इसको ट्रेडिशनल पेट्रोलियम रिकवरी टेक्निक्स के साथ। ऑयल सैंड्स contain about 10 to 15% bitumen and the remainder being sand or other inorganic materials. अगर ऑयल सैंड को 80 डिग्री सेल्सियस तक हॉट स्टीम में गर्म करते हैं तो ऑयल डिपॉजिट में से ऑयल रिकवर हो जाता है, बिकॉज एलिवेटेड टेम्परेचर बिटुमिन की विस्कोसिटी को कम करता है, जिससे ऑयल को अंडरग्राउंड पंपिंग में हेल्प मिलती है। Heating the bitumen above 500 degrees Celsius converts about 70% of it to a synthetic crude oil. Distilling this oil gives a good yield of kerosene and other liquid products in the middle distillate range. अगर हम बिटुमिन को 500 डिग्री सेल्सियस तक गर्म करते हैं तो 70% बिटुमिन जो है वो हमारा सिंथेटिक क्रूड ऑयल में कन्वर्ट हो जाता है और केरोसिन के साथ साथ कुछ दूसरे लिक्विड प्रोडक्ट्स भी हमें प्रोवाइड करता है। रिमाइंडर ऑफ बिटुमिन, डिस्टिलेशन के बाद जो बिटुमिन हमें मिलता है उसकी थर्मल क्रैकिंग की जा सकती है, जिससे हम गैसेस प्रोडक्ट्स और पेट्रोलियम कोक को बना सकते हैं।
Canada's oil sands are recovered using two main methods, drilling and mining. About 20% of the resource, known as bitumen, is found within 70 meters of the Earth's surface. These reserves, a mixture of bitumen and sand, are shallow and can be recovered through mining. Only 3% of the oil sands' total surface area can be mined. Oil sands mining is a three-stage process: mining, extraction, and tailings management. Typically, in mining operations, the oil sands are scooped up by large shovels and loaded into heavy haul trucks. The trucks deliver their load to a crusher, which breaks down the large clumps of bitumen and sand in preparation for transport. There are several methods of transport. One is hydrotransport. Water is added, and this mixture is sent to the extraction facility by pipeline. During extraction, the mixture is fed into an extraction vessel to be treated. Hot water is added, which helps separate the bitumen from the sand. Gravity pulls the sand to the bottom of the vessel while the bitumen floats. Sometimes the bitumen goes through a second separation process to improve the quality. The bitumen is removed as a froth and is now ready to be moved to an upgrader or sent via pipeline for export. Meanwhile, the mixture of sand and water at the bottom of the extraction vessel, also called tailings, is transferred to tailings ponds to settle and separate. As the solids settle out, the water on top is sent back to the mine to be heated and used again in extraction. Recycling water in this way reduces the amount of water needed for mining operations. All lands disturbed by oil sands mining operations, including tailings ponds, will be reclaimed to a self-sustaining landscape. Bitumen is a valuable resource that can be refined into transportation fuels such as gasoline, diesel, and jet fuel. It can also be used by petrochemical plants to create everyday products like cosmetics, textiles, plastics, and lightweight construction materials. Learn more at cap.ca.
Advantages and disadvantages of oil sand. Advantages: very large supply, it is available in abundance. Helps to keep oil prices relatively low. Enormous growth potential, less than 5% has been produced. Big economic driver for any country. Create jobs for people and stable resource. Disadvantages of oil sand: enormous greenhouse gas emissions, relatively low net energy return as compared to other resources, processing required a large amount of water, creates water pollution, destructive to forest, widespread habitat destruction, required expensive and risky pipeline to reach faraway markets. Let's have a look on reserves of oil sand in the world. Much of the world's oil is in the form of oil sands, although it is not all recoverable. While oil sands are found in many places worldwide, the largest deposits in the world are found in Canada and Venezuela, and much of the rest is found in various countries in the Middle East. This map highlights the distribution of oil by region. The blue bars indicates undiscovered oil reserves, while the green bars illustrate amount of discovered oil. This discovered oil in the unit of billion barrels of oil. Canada's oil sands are found in 3 deposits, the Athabasca, Peace River and Cold Lake areas in Alberta and part of Saskatchewan, with the greatest quantity found in Athabasca region. Okay. Now new topic is coal gasification. कोल गैसिफिकेशन के अंतर्गत हम इसका इंट्रोडक्शन, कंपोजिशन ऑफ सिंथेटिक गैस, यूजेस ऑफ सिंथेटिक गैस, रिएक्शंस इन्वॉल्व्ड इन कोल गैसिफिकेशन, टाइप्स ऑफ कोल गैसिफिकेशन, अंडरग्राउंड एंड सरफेस कोल गैसिफिकेशन और एडवांटेजेस एंड डिसएडवांटेजेस ऑफ कोल गैसिफिकेशन को डिस्कस करेंगे. व्हाट इज कोल गैसिफिकेशन? Coal gasification is the process of producing synthetic gas. Synthetic gas is a mixture of primarily of carbon monoxide, hydrogen, carbon dioxide, natural gas and water vapors from coal and water, air or oxygen. Now the composition of synthetic gas. Synthetic gases consist of 30 to 60% carbon monoxide, 25 to 30% hydrogen, 0 to 5% methane, 5 to 15% carbon dioxide, plus a lesser or greater amount of water vapor, a smaller amount of sulfur compounds, hydrogen sulfides, carbonyl sulfides, and finally some ammonia and other trace contaminants. Synthetic gas can be used for electric power generation, steam generation, heating process, chemical production, and liquid fuels production. Now reactions involved in gasification process. First equation represents the thermal decomposition of coal into volatile matter like hydrogen and hydrocarbon gas and char. Char is a residual solid content composed of fixed carbon and ash. Equation 2 indicates combustion with oxygen and formation of carbon dioxide. Equation 3 is a partial combustion with oxygen and supply heat of reaction required for gasification of carbon. Equations 4 and 5 are the main gasification reactions and are endothermic reactions. Equation 6 represents gasification with steam. Equation 7 is responsible for water-gas shift. It is the reaction between carbon monoxide and water. Equation 8 shows methanation or formation of methane. Now types of coal gasification. There are two types of coal gasification, underground and surface coal gasification. Underground coal gasification. This gasification process used to produce gas from coal in situ or on-site by injecting air or oxygen into non-mined coal seams and extracting the product gas via surface wells. The resulting synthetic gas can be used to produce electricity as well as chemicals, liquid fuels, hydrogen and synthetic natural gas. Let's have a look on process of underground coal gasification. Now, surface coal gasification. This type of gasification occurs in a gasifier, generally at high temperature and pressure vessel, where oxygen and steam are directly contacted with the coal, causing a series of chemical reactions to occur that convert the feed to synthetic gas and ash public slag. Now have a look on the process of surface coal gasification.
Let's take a closer look at coal gasification. Coal is fed into a vessel called a gasifier. In the gasifier, the coal is exposed to heat and pressure. Carefully controlled amounts of oxygen are released into the gasifier, allowing a portion of the coal to burn. This is called partial oxidation. The heat and pressure break up the molecular structure of the partially oxidized coal, causing a chemical reaction to take place. During the process, ash and other byproducts are trapped in the bottom of the gasifier and removed as slag or char.
Now, advantages and disadvantages of coal gasification. Advantages. It is one of the most abundant energy resource. It can be burned directly, transformed into liquid, gas or feedstock. Inexpensive compared to other energy resources. Can be used to produce ultra-clean fuel. Can lower overall amount of greenhouse gases. It is a leading source of electricity nowadays. It reduces dependence on foreign oil. Byproduct of burning can be used for concrete and roadways. Now, disadvantages of coal gasification. It is a source of pollution. It emits waste, oxides of sulfur, nitrogen oxide, oxygen. Coal mining mutilates the landscape. Liquidification, gasification require large amounts of water. Physical transport is difficult. Technology to process to liquid or gas is not fully developed. Solid is more difficult to burn than liquid or gases. It is not renewable in this millennium. High water content reduces heating value. Industry leads to health problems.